Everyone, good afternoon. Welcome to this video segment. In this segment, we shall be talking on chemistry, and our topic will be balancing chemical reactions. As you can see, we have 5 reactions that we are going to balance. Now, let's go to some things you'll see, the state of the compounds that you see there. We have a S. Whenever you see S, it means that the compound is in the solid state, or that the element is in the solid state. Okay, when you see L, that is the liquid state. When you see AQ, that is the aqueous state. And when you see G, is the gaseous state. Okay, of course, you know solids are compact molecules. The force of cohesion is strong. Then the liquid, the force of cohesion is not all that strong. And the aqueous state, the compound has been diluted a bit. And then the gaseous state, of course, the force of cohesion is very weak. So these are the compounds or the elements in their respective states. Okay, and we are going to balance them as usual. Now, we have 2 methods of balancing chemical reactions. We have the inspection method and the algebraic method. For this topic, I will be dealing with the inspection method. It's pretty much easy, but inspection method may not be able to balance all chemical reactions, especially the complex ones. So for the complex chemical reactions, I want you to view another video after this, where I will be teaching the algebraic method to balance the complex chemical reactions. And I can also illustrate the algebraic method with these as well, depending on the time of the video. Okay, so before you continue with this video, it is advised that you have an understanding of molecules, atoms, substances, compounds, ions. It's important that you view the video on those as well before you continue with this video. I will be talking mainly about using the word atoms in balancing. Okay, I'll be specifically using atoms rather than molecules. But it is advised that you view the videos on substances, molecules, and the rest of them. So, as you may know, we have that in a chemical reaction, the reactants combine to form the products. The reactants combine to form the products. Okay, and we have different types of chemical reactions: combination, decomposition, and the rest of them. We shall not be going into that right now. We shall be more focused on balancing chemical reactions. So let's start with number 1. We have the hydrogen gas combining with the oxygen gas to give water vapor or steam. Now you know that gaseous water in the gaseous state is known as water vapor or steam. Water vapor, or you call it steam. Okay. Now, the principle in inspection means that you have to list the elements of the reactant and the corresponding elements of the product. After listing it, you now write the number of atoms of each element. Now let us list the elements of the reactant here. We have hydrogen and oxygen. Once you have listed it, the elements of the reactant, you list it correspondingly in the products. Hydrogen, oxygen. That's the first thing you do. The second thing you do is to write the number of atoms of each element. Hydrogen has 2 atoms here. Oxygen has 2 atoms here. Hydrogen has 2 atoms here. Oxygen has 1 atom. So you see, hydrogen we have 2, 2. It's balanced. But oxygen we have 2, 1. is unbalanced. So that is why the equation is unbalanced. Okay? Unbalanced. So that means we have to balance this equation by balancing oxygen as well. So what do? We have 2 and 1. So the easiest thing we can do is to put 2 here. And when we put 2 here, it has balanced oxygen, that's right, but it has also unbalanced hydrogen. Hydrogen now becomes 2 times 2, which is 4. So we have 2 here and 4 here, 1, 2 and 2. 2 and 2 oxygen is balanced, but 2 and 4 hydrogen is not balanced. Now, if you can see this, I put this in parentheses to show you that there is a change. There is a change, and this is the new number of atoms of oxygen. I would suggest that you always do this to indicate a new change and the new number of atoms of the element. So how do we now balance this now? We easily put 2 here, and that becomes 4. So we now have 4, 4, 2, 2. That makes it balanced. Okay? This is now the balanced chemical reaction. Alright, let's go ahead. Of course, number 1, is a combination reaction. Number 2, the same thing, combination reaction. We have aluminum solid plus oxygen gas combines with oxygen gas to give aluminum oxide. Aluminum oxide solid. So let's list the elements. We have aluminum, we have oxygen. The same way we list them here, we have aluminum, we have oxygen. Aluminum is 1, oxygen is 2. Aluminum here is 2, oxygen is 3. So we have 1 and 2, 2 and 3. Now, in this case, you see that both of them are unbalanced or not balanced. So you now think 1 and 2, then 2 and 3. Which one is easier to balance? You see that 1 and 2 is easier because you can easily put 2 here. Okay, so we go ahead and put 2 here. We now balance aluminum. Oxygen 2 and 3. How do you balance this when you have 2 and 3? In this case. Okay, so in this case, we are going to go back to our video on solving systems of equations by elimination method. If you can recall, when you want to do elimination, if this is 2 and this is 3, all you need to do is you multiply this by 3 and you multiply this by 2. So that you now have 6 and 6. And then you can eliminate, you can cancel out. So this is the process we use in elimination method in mathematics. Okay, we are now applying it, we want to apply it in chemistry to balance it, to see the connection. So what we have to do is that we can multiply this by 2 for the oxygen, and then multiply this by 3, okay, for the oxygen here. As you can see, oxygen is intact here and also intact here. Okay, we don't have oxygen split up here. It's just single, intact. So we can easily do that. Now, if we have another element that has oxygen, for instance, then we might need to use algebraic method. We forget about the inspection method. Okay, when we do algebraic method, I'll let you know. But in this case, we have oxygen intact here and oxygen intact here. There is no other element that has oxygen, maybe like CO2. So we'll be splitting. No. If we have another element that has oxygen, then it's best to use algebraic method rather than inspection method. So let's go ahead. We put 2 here. And when we put 2, our oxygen is now 6. 2 times 3 is 6. But aluminum now is 4. It has unbalanced aluminum. So we go ahead and put 3 here to balance oxygen. So this is 6. Oxygen is balanced. Aluminum is still 2 here, but 4 here. So we have to balance it over here. So we erase this 2 here, and we just put 4. We put 4 here. Now remember, I erased this, but I didn't erase this, okay? This is just to show me the steps. the steps of what I did. Now this becomes the balanced chemical reaction. All right, let's go to the third one. The third one, we have a titanium chloride liquid combines with hydrogen liquid water. I'm sorry, not hydrogen liquid, liquid water to give titanium oxide solid and hydrochloric acid aqueous. Now some people call this hydrogen chloride. Now if it's in gaseous form, some people call it hydrogen chloride gas. But this is actually hydrochloric acid, aqueous hydrochloric acid. Okay, we list the elements. This is titanium, chlorine, hydrogen, oxygen. Okay, the same way we listed here, we listed in the products. Titanium, chlorine, hydrogen, oxygen. Titanium is 1, chlorine is 4, hydrogen is 2, oxygen is 1 for the reactants. For the products, titanium is 1, oxygen is 2, okay, write it under oxygen. Chlorine is 1 and hydrogen is 1. So we have 1, 1, 4, 1, 2, 1, 1, 2. Okay, so we look at 4, 1. We can easily balance that. Okay, let's put 4 here. When we put 4 here, we now find out that our chlorine is 4, but that has also made our hydrogen to be 4. Okay, now some of you might ask me, why did I balance 4, 1 first instead of 2, 1? Some people might ask that question. Why did I, first of all, I have 4, 1, 2, 1, 1, 2. Why did I go first with a 4, 1? Now, my answer is that, my response is that you might choose to balance any way you want to. Okay? You can put 2 here. If you had put 2 here, that would balance hydrogen. And that would that would still unbalance chlorine. And that would make you 2, because this chlorine will be 2, and you will still have to balance it again. But whichever way you choose to do, that's fine. You might start with 4, 1, you might start with 2, 1, you might start with 1, 2. Okay, but it will just take you more steps, but you will still arrive at the same answer. So it doesn't matter. Just start with the one that you can easily be balanced. Okay, 4, 1, 2, 1, you can easily balance it. So whichever way, that's fine. All right, this is 4, 4, this is 2, 4, and this is 1, 2. So what do I do now? I can go ahead. This is 4 hydrogen, this is 2. I go ahead and put 2 here, and that balances the hydrogen to be 4, and it also balances the oxygen to be 2. So I now have 1, 1, 4, 4, 4, 4, 2, 2. That balances the oxygen as well. This is now the balanced chemical reaction. Okay, we're coming close. Number 4, iron 3 oxide, solid, combined with carbon, solid carbon, to give iron solid, solid iron, plus carbon 4 oxide, or carbon dioxide gas. Let's list the elements of the reactant. We have iron, oxygen, carbon. The same way we have iron, oxygen, carbon. Iron is what here? 2. Oxygen is 3. Carbon is 1. Iron is 1. Oxygen is 2. Carbon is 1. Okay? So we have 2, 1, 3, 2, 1, 1. Carbon is the only one that is balanced now. Let's go ahead and balance iron. 2, 1, 3, 2. 2, 1 is easier to balance than 3, 2. So we go ahead and put 2 here. That balances the iron to be 2. Now we are stuck with oxygen. In this case also, oxygen is distinct. There is no other element containing oxygen. Okay, we have 3, 2. 3, 2. And we see that oxygen is distinct. like it's in only one element, there is not another element containing oxygen. If there was another element containing oxygen, like if this was CO, maybe CO, carbon monoxide, then I would suggest that you use algebraic method. Okay, but oxygen is distinct here and is distinct here, so you can easily use the method we use for elimination. You multiply this by 2 and multiply this by 3, gives you 6, 6, and you balance it. So I'll go ahead and multiply this oxygen by 3, and when I multiply it by 3, oxygen is now 6, and carbon is now unbalanced, carbon is now 3. Okay? Then I multiply this oxygen by 2. Here oxygen is now 6. Excuse me. And iron is now 4. Okay? So it has unbalanced everything again, except that oxygen is balanced. I go ahead, I have 1, 3, 4, 2, whichever one you want to start with. I can easily put 3 here to balance carbon. 3, that's balanced. And then iron is 4 here. So I erase these 2. And I put 4. So this is 4, 4, 6, 6, 3, 4. That makes it balanced. Alright. The last one that we shall do in this video is number 5. Iron 3 hydroxide. This is iron 3 hydroxide solid combined with aqueous tetraoxosulfate 6 acid. This is what we call a sulfuric acid. The old name is sulfuric acid. The new name is tetraoxosulfate 6 acid. To give iron 3 tetraoxosulfate 6 and liquid water. Okay, let's list it. Iron, oxygen, hydrogen, sulfur. Iron, oxygen, hydrogen, sulfur. The same way we list it here. Iron, oxygen, hydrogen, sulfur. Iron is 1. Oxygen, now be very careful here. Look, this parenthesis 3 means that oxygen is 3 atoms and hydrogen is 3 atoms. Be very careful here. This one means that sulfur is 3 atoms, but oxygen is 12 atoms. Okay? So here oxygen is 3 atoms. For here, for this reactant, then for this reactant also, oxygen is 4 atoms. So 4 plus 3. This is 3 for oxygen and 4 for oxygen here. So 3 plus 4 is 7. Okay. Hydrogen is 3 here, but it's 2 here. So 3 plus 2 is 5. Sulfur is 1. Okay, over here, iron is 2. Oxygen, 4 times 3 is 12 here. 12 plus 1 here, 13. Hydrogen is 2 here, 2. Then sulfur is just 3. Alright. We have 1, 2, 7, 13, 5, 2, 1, 3. Iron 1, 2 is easier to balance, so we put 2 here. When we put 2 here, iron will be 2, right? Oxygen will be 3 times 2. 3 here times 2, which is 6, plus 4 here, 10. Oxygen will now be 10. Hydrogen will be 3 times 2, which is 6, plus 2 here, 8. Okay, we now have 2, 2 is balanced, 10, 13, not balanced, 8, 2, not balanced, 1, 3, not balanced. So let's go ahead. Let's forget about oxygen and hydrogen now, because we see here oxygen and hydrogen is almost in, it's not distinct. So let's go ahead and balance sulfur first, okay? Because if we keep trying to balance oxygen and hydrogen, we might still come back to balance it again. So let's go ahead and balance the other ones, and then we'll deal with oxygen and hydrogen later. So 1, 3, we put 3 here, 3 here. So sulfur is 3 now, but hydrogen, it has changed hydrogen and oxygen. So hydrogen is 6 here, plus 6 here. Hydrogen becomes 12. Okay? And oxygen becomes 4 times 3 is 12 here, plus 6 here becomes 18. 12 plus 6, 18. Alright, so we now have 18, 13, and 12, 2. So easiest one to balance is 12, 2. 18, 13 is more difficult to balance. So 12, 2. So we put 6. We put 6 here. And when we put 6 here, we now have that hydrogen is 12. Okay. Then oxygen will be 6 here, plus 12 here, and that gives us 18. That makes it balanced. Alright, thank you for listening to this video. Please watch out for the next video using an algebraic method, because with this method you can balance any chemical reaction. Anyone, no matter how complex it is. Okay? For my moment of conscience, since I have talked about the ladies, I will now talk about the guys, the men. When I talked about the ladies, I pleaded with their conscience to keep their babies, not to abort their babies. Abortion is bad. Right now, I'm talking about the guys now who give those babies. Okay, now the guys, please, we should be responsible. We should be responsible men. We should not be men that will give so many kids, so many products, and will not take care of the products. Guys, if you have the power to engage in sexual activity, and you now mix with the reactants to give products, which are the babies, you should take care of those products. You should take care of the babies you give. Now, it is not just unjust, but it is morally unacceptable for you to have so many babies and you can't even take care of them. Please, if you have that strength to produce babies, to give the products, please be man enough to take care of your babies. Okay? Be man enough to be responsible. Now, I can imagine a guy who has so many babies and he doesn't even know the names of all his babies. Please, guys, let's have conscience. Let's apply the conscience that we have. If you have so many babies, please, you have to take care of those babies. Now, if you know you're not going to take care of them, please don't have many babies. And that's not to say that you will now say, kill those babies. No, that will not solve the problem. Abortion will not solve the problem. It's not going to solve it. Okay? So please, I'm appealing to your consciences, guys, to be more responsible and take care of, when you marry and produce kids, please take care of those kids. Okay? Alright, folks, thank you, and thank you for listening to this video, and we'll see you again. Take care. Bye.